Good evening, dear all. Today we are going to explain thermal physics solutions for the test questions. See, already we completed the two part of thermal physics in our classroom. Many students have a doubt about the test questions. So we selected today thermodynamics and kinetic theory part questions, and we are solving that questions correctly. See, actually, as I explained before, these three chapters are very important for our NEET examination, so we can crack the questions. Come with me. Now we are explaining the first question. Now please see. CV and CP denotes the molar specific heat capacities of a gas at constant volume and at constant pressure respectively. Then Cp minus Cv is larger for diatomic ideal gas than for monoatomic ideal gas. Cp plus Cv is larger for a diatomic ideal gas than for a monoatomic ideal gas. Cp by Cv is larger for a diatomic ideal gas than for a monoatomic ideal gas. Cp minus Cv is larger for a diatomic ideal gas for a monoatomic ideal gas. So here in this question, two terms are there, they are changing. Cp minus Cv and Cp plus Cv. You know, we have the idea, according to Mayo's relation, Cp minus Cv is equal to R. So, you know, R is an ideal constant, you know, ideal gas constant. So, Cp minus Cv will be same for all. So, we can say, if you are considering the first option, Cp minus Cv for larger diatomic, that is wrong. And it is larger for diatomic ideal gas than for monoatomic ideal gas, that is also wrong. Now, we have Cp plus Cv and Cp by Cv. You know, Cp plus Cv is meaningless. It does not stand for any term in physics. So, it is no meaning is there. Now, we have Cp by Cv. What is Cp by Cv? Cp by Cv is ratio of specific heat. We know Cp by Cv is equal to gamma. You know, this ratio of specific heat, that is gamma, is for diatomic we studied and monoatomic we studied. For diatomic, what is the gamma value? Gamma value is 7 by 5. For monoatomic, what is the gamma value? That is equal to 5 by 3. So we can say 7 by 5 is more than 5 by 3. So this picture is clear. Cp by Cv is larger for diatomic ideal gas than for monoatomic ideal gas. So the right option is option C, that is the relation between Cp and Cv. So it is a very important point here, that is Cp-Cv relation. Cp minus Cv is constant for any number of moles and any gases, that is equal to R. But Cp by Cv is different for monoatomic and diatomic gas molecule. Now we are explaining the next question. Look, a graph of pressure versus volume for an ideal gas for different processes as shown. In the graph, what the curve OC represents. We know this PV graph is very important for examination. We explained many times. Here pressure remains constant everywhere. Pressure is same. So OA is isobaric. Pressure remains the same. So it is isobaric. And we can say at the point OD, you know, everywhere, look, the x-axis is volume. So everywhere volume remains the same. So we can say OD is isochoric. Isochoric where volume remains the same. Now we have OB and OC will be there. You know, which is more steeper? You know, we studied that is isothermal is more steeper than adiabatic. So if we are considering that point here, we can say OC is more steeper than OB. So OB represents isothermal and we can say OC represents adiabatic. So the right answer here, that is OC represents adiabatic. They are asking what OC represents. So it is adiabatic process. Right answer is option D. This question, many of the students corrected this question in the classroom. So it is adiabatic process. Now we are explaining question 3. du plus dw is valid for. We know we have the first law of thermodynamics. According to the first law of thermodynamics, what is the equation? We know dq is equal to du plus dw. That is the first law of thermodynamics. So we can say here du plus dw 0 given. So du plus dw equal to 0 means we can say dq equal to 0. No heat is transferred between the systems and surroundings. So we can say that is which process? Adiabatic process. So no heat is transferred between the systems and surroundings. So it is adiabatic process. Right answer option A, adiabatic process. Now we are explaining the next question now, question 4. Question 4 is a very important question. So, you know that is a cyclic process ABCD is shown below in the given PV diagram. In the following answers, the one that represents the same process as in PV diagram is one. That's the question. So, you know, here we can say a PV diagram is given here. We can name each process. Simply see, look, here AB is there. At every point of this AB, pressure remains constant. So we can say AB is isobaric process. AB is isobaric. Then what is BC stands for? You know, BC is the curve, you know, so that we can say, so BC is isothermal process. BC is isothermal process. It's isothermal. So what we can say means, look, AB isobaric and BC isothermal. What is CD? You know, CD is isochoric because everywhere volume same. At any point of this curve, volume, you know, see, volume remains the same here. So CD is actually isochoric. So when we are considering this picture now here, you know, look, AB, BC and CD, we can say what is the correct option. Look in the first one, look, process AB, you know, it's a PT graph. See the axis here, this is PT. So everywhere pressure remains the same. So we can say AB is isobaric, right? Now look, for BC, you know, BC everywhere temperature same because this axis is temperature graph. So we can say everywhere temperature same. So BC is isothermal. That's right. And then we can say, suppose we are considering for CD. What is happening? Look, in the case of CD, when temperature and pressure directly proportional, so CD isobaric. So we can say this is an option that we can put right. But you know, look, we are checking now option B. In option B, what is the idea? You know, AB they marked as isochoric. So that is wrong. Now in option B, what's the problem? You know, look, here you know, AB is not isobaric. So that is wrong. And here in this question, look, AB is isochoric. That is wrong. So the right answer is option A only. So we can say A is the right answer for the process now. So I'm repeating, these questions are repeating many times in the exam. So they are giving PV diagram, or they are giving PT diagram, or they are giving VT diagram, and they may ask the requested to draw another diagram, or means which is the right option for this one. So we have to identify the process. Rest to work is easy only. So we can get the right answer here. Option A, the right one that we explained. Now question 5 we are trying now. So look, an ideal refrigerator has a freezer at a temperature of minus 13 degrees Celsius. The coefficient of performance of the engine is 5. What is the temperature of the air? That's the question. Air means to which the heat is rejected. You know the coefficient of performance of refrigerator. Even though refrigerator is the deleted topic, we know that is coefficient of performance of refrigerator is an important topic for NEET. We studied in the classroom. What is the formula? Beta is equal to T2 divided by T1 minus T2. That is the coefficient of performance. So, beta is equal to T2 by T1 minus T2. What is T2? Always in this type of question we studied T2 should be less than T1. And one more idea, that is, that is if you are considering this T2 and T1, you want to write all in Kelvin. T2 should be in Kelvin, T1 also should be in Kelvin. So here the temperature of the freezer, that is lower temperature. So T2 given minus 13 degrees Celsius. We are converting that into Kelvin. So that is equal to minus 13 plus 273. That is equal to 260 Kelvin is there. So we have a T2 260 Kelvin. Substituting that answer here. So beta is given already. Beta is equal to, in this question given, that is 5. So I'm writing 5 is equal to 260 divided by T1 minus 260 is there. Just cross multiple. So we can say that is 5 T1 minus 5 into 260 equal to 260 is there. So we can say T1 is equal to 6 into 260 divided by 5. Simplifying, you got the answer 312 Kelvin. So to this 312 Kelvin, we want to convert into Celsius, because here 325 Kelvin is not the right answer. Then you want to convert into Celsius. So 312 Kelvin minus 273. So you are getting that is equal to 39 degrees Celsius. So the right answer is 39 degrees Celsius. I am repeating there once more. Coefficient of performance of refrigerator is very important. The formula beta is equal to T2 by T1 minus T2, where T2 will be always lower temperature, T1 will be always higher temperature, and we can say T2 is the temperature of the freezer and T1 is the temperature of the surroundings. So this formula very important, the coefficient of performance. Now we are explaining question 6. Look, a Carnot engine. Carnot engine takes heat from a reservoir at 6 to 7 degrees Celsius and rejects heat to a sink at 27 degrees Celsius. What is the efficiency? We know efficiency of heat engine, Carnot engine we studied. Eta is equal to 1 minus T2 by T1. As before, here also Carnot engine also T2 will be lower temperature and T1 will be higher temperature. Convert that into Kelvin, it's must. So we can say T2 is, that is here given 27 degrees Celsius. So 27 plus 273 equal to 300 Kelvin, and T1 is given, that is equal to 6 to 7 degrees Celsius. So 6 to 7 plus 273, and that is equal to 900 Kelvin. So values are there. So substituting the datas now, 1 minus 300 by 900. So that is 1 minus 1 by 3 is there. Simplifying, you will get that is equal to 2 by 3. So the right answer is 2 by 3. So we can say efficiency eta is equal to 1 minus T2 by T1 is there, and that is eta is equal to 2 by 3 is coming. 2 by 3 is the right answer. Now we are explaining the next question, question 7. Now look, Carnot engine efficiency, I am repeating once more. Carnot engine efficiency question, 1 minus T2 by T1. 1 minus T2 by T1 is there. And T2 will be temperature of the sink and T1 is temperature of the source. Now we are going the next question. A Carnot engine has an efficiency 1 by 5. Efficiency becomes 1 by 3 when temperature of sink is decreased by 50 Kelvin. What is the temperature of the sink? We can say efficiency given, that is equal to 1 by 5. Efficiency is 1 by 5 given. Then they are asking, when the temperature of the sink decreased by 50 Kelvin, what is the temperature of the sink? So I can write 1 by 5 is equal to 1 minus T2 by T1. So I am taking T2 by T1 to this side. So T2 by T1 is equal to 1 minus 1 by 5, and that is equal to 4 by 5. So T2 by T1 is 4 by 5. Now we are explaining, if the temperature of the sink decreased by 50 Kelvin, so what is the new efficiency? So eta dash is equal to 1 minus T2 minus 50 divided by T1. So that is given, that is equal to 1 by 3. So we can say 1 by 3 is equal to 1 minus T2 by T1, minus of minus becomes a plus 50 by T1 is there. And here what is the value? T2 by T1, 4 by 5. So we are writing 1 by 3 equal to 1 minus 4 by 5 plus 50 by T1. Take all terms to this side. So 1 by 3 minus 1 plus 4 by 5 is equal to 50 by T1 is there. Simplify the terms correctly. So it's coming, look here, 1 by 3 minus 1. So simplifying, it's 1 minus 3 by 3. So minus 2 by 3 plus 4 by 5 is equal to 50 by T1. Make the common denominator multiple into 15. So we can say here minus 10 by 15 plus, and here multiple by 3. So 12 by 15 is equal to 50 by T1. So we can say 2 by 15 is equal to 50 by T1 is there. So we are getting the T1 value now. T1 is equal to 50 into 15 divided by 2. So we are getting the formula, that is equal to 50 by 2 is 25. So 25 into 15 is there. So what's the answer coming now? We can say 25 into 15 is equal to, this answer is not correct, this answer is not correct. So it will be 375 Kelvin. So we got the answer, that is equal to 375 Kelvin is the answer for 5 into 15 is 75 and 20 into 10 is there correctly. The value we are getting 375 Kelvin, the right answer. Now question 8 we are trying now. Please see question 8. This question when we are considering, look there. Suppose I am considering the question here correctly. Look, the figure shows the figure shows the PV plot of an ideal gas taken through a cycle ABCDA. So the part ABC is a semicircle and CDA is half of the ellipse. Then, so that's the question coming. So how we will answer this question now? Look, here the figure shows a PV plot of an ideal gas taken to a cycle ABCDA. Okay, so each point we can consider. So look, first one, the process during the path A to B is isothermal. First one. So we are checking now whether A to B is isothermal. There we can say, look, the process A to B is not isothermal because isothermal graph is like this. It should be open upward. So we can say, yes, right. Temperature of the source. Yes, Amirunusi, I am coming to that question now. Look, they are asking what is the temperature of the sink now correctly. So we are calculating T1 and you will get the T2 value from this, that we can calculate correctly. Okay, now there the next one, see, look, for this one, the process during the pass, so A to B is not isothermal, you know, see, so that's correct. So this statement is wrong. Okay, now the next one, heat flows into the gas during the path B to C to D. So that's the point. Look, you know, we are considering the process here B to C to D. What is the heat flowing? How whether heat absorbed or we can say heat rejected. We know the formula. Delta Q is equal to delta U plus delta W is there. You know, here B to D, please see, B to D process volume is decreasing. So we can say, look, if volume is decreasing, work done will be negative. So we can say delta W is negative. So that's the point correctly. Work done is negative. Now the point here we can say it is a cyclic process. For cyclic process, delta U will be, if you are considering, that will be negative, you know, delta U, cyclic process, delta U is 0. So if delta U 0, then delta W negative means delta Q will also negative. So delta Q negative means what's the meaning? Heat flows out of the system. Heat is not flowing into the system. So we can say this option is also wrong. Now the next one, you know, work done during the path A, B, C is 0. Look, work done during the path A, B, C. You know, we studied an important point. How we can calculate work done? Area under PV diagram gives the amount of work done. So we can say here area under ABC is there existing. This much area is there. So we cannot say that work done is 0. So that answer is also wrong. And now the next one, look, positive work is done by the gas in the cycle ABCDA. So we can consider in the process ABCDA, look, the process is clockwise. We studied if a thermodynamic process is in clockwise, we can say the work done is positive. If a thermodynamic process is there in anti-clockwise, the work done will be negative. So the right answer, we can say option D, positive work is done by the gas in the cycle ABCDA. Now the next one, we are trying question 9th. What is question 9th? Please see, look. First law of thermodynamics is based on what? You know, first law of thermodynamics is based on law of conservation of energy. So we can say option B, the right one. It's a direct question. First law of thermodynamics is based on law of conservation of energy. Now we are explaining the next question, question 10. So please see question 10. The PV diagram of 2 gram of helium gas for a certain process A to B is shown in the figure. What is the heat given to the gas during the process A to B? A to B. Dear, you know, we can consider what is this process A to B. PV diagram is like this. So we can say it's very clear. Pressure is if you are considering from pressure is increasing, volume also increasing. So P directly proportional to V, that is happening at constant temperature. It's a very important point. Look, we know that is, look, we studied that is at constant temperature. Please see, at constant temperature, pressure is inversely proportional to volume. P inversely proportional to volume. So here, look, the point here, initially here the pressure and volume, P naught and V naught. Here we can say the pressure and volume 2 P naught and 2 V naught will be there. So we can find the temperature at both cases now. Starting point, what's the temperature? A to B. So at the point, we can say if you are considering at the point, initial point, A, what is the starting point? Temperature and pressure. So if you are considering the point there, we know PV is equal to nRT. So temperature is equal to PV by nR. So we can say that is P naught V naught divided by nR. So temperature here, initial temperature TA will be there. Now we have, that is the next final case, 2P naught and 2V naught are there. So we have the 2P naught into 2V naught is equal to NR into TB. So we can find TB is equal to 4P naught V naught divided by NR. So that is equal to 4TA. Temperature is increasing. So we can say here, it's very clear, from A to B, temperature also increasing. Now the question here, how much heat is we are calculating? Area under the graph we can calculate now. So what is area under the graph gives work done. So we are calculating work done is equal to area under the graph. What is the area under the graph here? It's a trapezium. So sum of parallel sides into the vertical distance into half. So I can write half into, what is the sum of parallel sides? First side is P naught, other one is 2P naught. So I can write that is equal to P naught plus 2P naught is the parallel side. And what is the vertical distance? 2V naught minus V naught, that is equal to V naught is there. So we are getting that is equal to 3P naught V naught divided by 2 is the work done. So we are getting the formula 3P naught V naught divided by 2 is the work done. Now there we are trying question 11th now. So what is question 11th? Please see, look in this question. If 150 joule of heat is added to a system and work done by the system is 110 joule, then the change in internal energy will be. So how we will find the change in internal energy? What's the formula? Delta U. We know the formula. Delta Q is equal to delta Q is equal to delta U plus delta W. So they are asking the work done. So we can say delta internal energy. So delta U is equal to delta Q minus delta W is there. You can see here 150 joule of heat is added. So heat added is 150, and we can say work done by the system, work done by the system is positive. So we have the formula 150 minus 110. So the answer will be 40 joule. Option A, the right one. So the right answer is option A, that is equal to 40 joule. Now we are trying question 12. So what is question 12? Please see, look there. The ratio of specific heat of gas is gamma. The change in internal energy of 1 mole of the gas when the volume changes from V to 2V at constant pressure P is. So we can say that is the process is happening at constant pressure. The volume changes from V to 2V. What is the change in internal energy? We studied there is a very important formula. The change in internal energy is equal to NCV delta T is there. So please see, for 1 mole we can say, that is, so question 10 we need to find the heat given. Yes, I'm coming now. So please see, delta, we are doing question 12 now. So here number of moles is given. So that is equal to 1. So we can say CV delta T is there. Here, but CV is not given in this option. So I want to change this CV in terms of gamma. So how this is possible? We know the formula. Gamma is equal to CP by CV. CP is equal to CV plus R divided by CV. So we can say CP is equal to CV plus R. Already we know the formula, because CP minus CV is equal to R. Now CV I am writing, that is CV by CV, 1 plus R by CV is gamma. Take this R by CV to the side. So R by CV is gamma minus 1. So what is CV? Now take the reciprocal, you are getting CV. So I can say CV is equal to R by gamma minus 1. So instead of CV, I can write the formula, that is equal to R by gamma minus 1 into delta T is there. So now what is this R delta T stands for? We know according to the equation of state, PV equal to nRT is there. So if I am changing the temperature here and they said constant pressure, so volume only changing. So P delta V is equal to nR delta T is there. So look, one mole. So I can say R delta T is equal to P delta V is there. So instead of R delta T, I am writing P delta V by gamma minus 1. Look, what is the change in volume? Volume changes from V to 2V. So we can say P into, that is 2V minus V by gamma minus 1. 2V minus V is V only. So we are getting the final answer, that is equal to PV by gamma minus 1 is there. So PV by gamma minus 1. Dear, this type of question, we practiced many questions in the classroom also. This type of questions are very important for examination. I am repeating that question once more, please dear. See, look, you know, we have the formula delta U equal to NCV delta D. We are saying it is one number of mole. So CV delta D. CV, I want to replace in terms of gamma. This same question we did in classroom. Gamma equal to Cp by Cv, Cp equal to Cv plus R divided by Cv. So we can say Cv by Cv is 1, 1 plus R by Cv is there. So R by Cv is gamma minus 1, Cv R by gamma minus 1 is there. So I am substituting that value here, R by gamma minus 1 into delta D. Please see, R by gamma minus 1, where R delta D I am changing now. This term I am changing, R delta T. R delta T is equal to P delta V. So P delta V divided by gamma minus 1. Delta V is 2V minus V because it's given here. So we can say PV by gamma minus 1. Right option is option C. So this relation is very important for examination. Now dear, the next one we are trying, question 13. The thermodynamic process in which no work is done by the gas. Everyone knows, we know what is the process in work done is equal to P delta V is there, and as there is no work done, we can say that is work done is equal to 0 means delta V is equal to 0. Delta V 0 means the process will be isochoric process. So right answer option D, it is an isochoric process is there, isochoric process. Now we are explaining question 14. Which of the accompanying PV diagram best represents an isothermal process? Direct question, everyone knows. We can say that is option B the right one, that is it represents a isothermal process. Isothermal process. Now the next one, an ideal gas is compressed isothermally. Ideal gas is compressed isothermally until its pressure is doubled and then allowed to expand adiabatically to regain its original volume. Gamma is 1.4, 2 raised to minus 1.4 is equal to 0.38. The ratio of final to initial pressure that we want to find out. So how we will work this question? This question is also a tricky question, but we can work. There it is compressed isothermally. So I am assuming initial pressure is P1 and initial volume is V1. And now look, now it is changing, isothermally changing. So that's next one I am saying, its volume is V2 and pressure is P2. For an isothermal process, we know the formula, P1 V1 is equal to P2 V2 is there. That's isothermal process. P1 V1 equal to P2 V2. Now here we can say that the volume doubled. So now that is until its pressure is doubled. So the data given, P2 is equal to 2P1. So I can write P1 V1 is equal to 2P1 V2 is there. So P1 and P1 cancels. We are getting V2 is equal to V1 by 2 is there. So V2 is V1 by 2. So that is the final volume. So we got a volume is V1 by 2. That is isothermal process. Now it is changing to adiabatically. So for adiabatic change, what we can say means, look, P2 V2 is changing into P3 V3 is there. So it is changing from P2 V2 to P3 V3. So for adiabatic process, what is the formula we studied? That we can say P2 V2 raised to gamma is equal to P3 V3 raised to gamma. We studied for adiabatic process, PV raised to gamma equal to a constant. So we have P2 V2 raised to gamma is equal to P3 V3 raised to gamma is there. And here, look, suppose I am considering this V3 now and V2 now. V2 we got V1 by 2. So I can write P2 into here. P2 is 2P1. I am writing instead of P2, it's given 2P1. V2 is V1 by 2 all raised to. Instead of gamma, what is that? 1.4. 1.4 is equal to now P3. Look, they are saying adiabatically to regain its original volume. Can you say what is the original volume? The original volume that you taken, it is V1, initial volume. Because we are starting from the initial one. So we can say V3 becomes V1 now. So V1 raised to, and the power is here again 1.4. So it's clear now. Look here, we can cancel the terms. So that is V1 raised to 1.4. V1 raised to 1.4 is cancelled. Now we have the formula. Look, 2P1 into, then here we have the formula 1 by 2. So this 1 by 2 means I can take a 2 raised to minus 1.4. How it is coming? 2 raised to, because here 1.4 over V1 is cancelled. Denominator 2 is there. Take that 2 into the numerator. So we can say 2 raised to minus 1.4 is equal to P3 is there. Now here we can rewrite. So that is 2P1 into, look, 2 raised to minus 1.4 is given, the value 0.38. So 0.38 is equal to P3. Look, 2 into 0.38, how much it is coming? 0.76 P1 is equal to P3 is there. So if they are finding the ratio of final to initial pressure, so P3 by P1 is equal to 0.76 is to 1. So the right answer is 0.76 is to 1 is the right answer. So there I'm explaining the problem once more from the beginning. Please, I know in the test questions, very less students only make this question correct. So I'm explaining once more the question. Please see. First of all, it is compressed isothermally. Compressed isothermally. So isothermal means we can say P1 V1 changing into P2 V2. So we know that is P1 V1 is equal to P2 V2 is there. Now they are saying, the point there, pressure doubled. So P2 is equal to 2P1. So I'm substituting P1 V1 is equal to 2P1 into V2 is there. So V2 is equal to V1 by 2. Now dear, that is changing into P2 V2 changing into P3 V3 by using adiabatic process. So in an adiabatic process, what's the idea? PV raised to gamma equal to a constant. So we have a P2 V2 raised to gamma is equal to P3 V3 raised to gamma. Substituting the value. So instead of P2 2P1, V2 is V1 by 2 raised to 1.4. And here P3 V1 raised to 1.4. Look, 1.4 is cancelling only for this V1, Now here we are considering, look, V1 raised to 1.4 is cancelling, but the denominator 2 still there. So I'm taking that correctly to the point now 2P1, 2 raised to minus 1.4 is P3. Now what is given the data? 2 raised to minus 4 is 0.38 given. So substituting that. So 2P1 into 0.38. 0.76 P1 equal to P3. P3 by P1 is 0.76 divided by 1. So that's the right option correctly. I think it's clear for you. So So, that is the next class. See, today I think the next section is not there, and we'll see tomorrow. We'll give the updation tomorrow. Thank you very much. I'm Shamim signing off.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.